This is section 2.3, parallel lines and triangle angle sums. We are on page 83 of your workbook, and your I can statement is I can solve problems using the measures of interior and exterior angles of a triangle. We've got two important theorems for today for you to take notes in before you turn the page. You can literally write them anywhere on that Explore and Reason page. Pause, write down these two theorems. All right, now that you're back with me, we're going to do example 1, which says, given two angle measures in a triangle, can you find the measure of the third angle? And to explain. And from one of the theorems that we just took notes on, yes. Our answer is yes. We know, we just learned, we know that all angles add to be 180. I'm going to abbreviate. We add to be 180 degrees. So if we were to set up just a little example equation, we have three angles in a triangle, and we know that the measure of angle 1 plus the measure of another angle 2 plus the measure of the third angle in the triangle has to equal 180 degrees. So if we were given two angle measures, like if we were given 1 and 2, we can add those together and then solve for the measure of angle 3 using our solving equations ability, which is what we are about to do. We're actually going to jump down to example 3, and we're going to look at this figure, and we are going to determine what are the values of x and y in each figure. And so I'm going to give you a second to look at that figure, look at where the x is, look at where the y is, and think about what would be our first step in finding our x value. We're going to notice that the x value lies in a triangle that has two other measures already given. So we know that we can add those up and they should equal 180. So we know that 35 plus 96 plus x needs to equal 180 degrees because those are the three measures of that triangle. Now I'm going to undo those lines because those angles are not congruent and I don't want to be misleading. So if we actually add 35 plus 96 plus x, we want to solve to get 180. 35 plus 96 is 131. And if we subtract that, x is going to equal 49 degrees. And that is actually an answer that they wanted from me. So I'm going to put a box around my answer to help signify that that is one of my answers. Because in this problem where we're trying to find x and y, there's two answers. So I want to be really clear with my answer. Now the second thing we want to do is we are going to have to figure out the measure of this angle y. Well, if we look at this triangle that it is a part of, we know that this angle measures 77 degrees. But do we know the measure of that third angle? We don't. So how can we figure that out? And that's going to be what we have to do, is we're going to have to notice that the unknown angle is a straight angle. And what do we know about a straight angle? It adds to be 180 degrees. So again, we don't know this mystery green angle right here, like we don't know that, but I do know that that mystery angle plus 96 should equal 180 degrees because it's a straight line. So if I actually subtract that 96, that tells me that that mystery unknown unmarked angle is 84 degrees. So I don't have a question mark here anymore. I know that this angle is 84 degrees. And now I can use that information to find that third angle y. So if I actually wanted to find that third angle y, and I'm just doing the steps 1, 2, and 3 for you all, like writing them out step by step, I know that this is 77 and this is 84, so I'd have 77 plus 84 plus that y equals 180 degrees. I can add 77 and 84, then subtract that from 180, and I would solve to find that y equals 19, which again is one of my answers, so I am going to put a box around that because that's what it asked me for. Notice how it didn't ask me for what that unknown angle was, but I did need to find it, so it was important, but it wasn't technically one of my answers. So we want to put a box around our answers, and that's just going to help you get in the habit that moving forward in your mathematical career, in your like high school math classes, putting a box around your answer to help signify that is my official answer. So you guys take a second and try part B. All right, you tried it. What did we notice? Did we find that x equals 64? Awesome, because we added up those 3 angles in the second triangle. And then here we had to notice that we had a pair of vertical angles. These were vertical angles. Wow, that is way too big. And that meant that this unmarked angle here was also 64 degrees, that then we could use to find y is 74. All right. Now we're going to move to example 4, which is about exterior angles. And we actually have a theorem for this, but we're going to try and do part A without it, and then I'll introduce the theorem to you. So that way you can kind of see where it comes from. So we want to find the value of x, and notice that x is an exterior angle. So we have this interior angle of the triangle, and x is that angle measure that would be formed if part of that triangle just kept going. And that could happen on any side of the triangle, like the line can just keep going. I'm going to actually remove those. And let's get started on trying to find our variable x. So how do we think we could find this? I don't know this variable and I don't know this, but I do know that this is 54 degrees and this angle is 57. So using what we just learned, I can find that interior angle. So let's do it. Let's find that interior angle. We don't know what it is, some mystery unmarked angle, but that angle plus 54 plus 57 needs to equal 180 degrees because it's the 3 angles from the triangle. So if we do that and we solve, then that means that that angle equals 69 degrees if I add those together and I subtract them from 180. So now it's not a mystery anymore. I can say with certainty that this is 69 degrees. Do you guys see how we can find this angle from here? What do those 2 angles need to add to be since they are formed on a straight line? They have to add to be 180 degrees. So now we know that 69 plus x should equal 180. So if we subtract that 69, x actually equals 111 degrees. And that's how I can find my answer. So we used what we know about the measures of inside a triangle to help us find that exterior angle, which is going to lead us to the triangle exterior angle theorem that you can take on the little left-hand side, that the measures of each exterior angle of a triangle, which is what we just found, equals the sum of the measures of its 2 remote interior angles. So remote means kind of like just across from. So the 69 degree angle was part of the angle to make it a straight line. But the 54 degrees and the 57 degrees are the 2 remote interior angles, interior being on the inside. And if we check that out, 54 plus 57 does equal 111. So notice how if we add these 2 up, we got what that exterior angle was. And that's kind of a quick way you can do this moving forward, was if you want to know this exterior angle, you can use its 2 remote interior angles, add those up to find it. So try part B, use either the method that we just did or the theorem that you just learned. Try it. And what did you find? There was 2 ways you could have done it. You could have used the 2-step method that we did, or, wait, what do you see? Oh yeah, the interior angle is our variable. So you also could have set it up as x plus 49 equals 104, because the two remote interior angles add to be that exterior angle. And if you subtract 49, 104 minus 49, you end up with 55, which is what the original method also found. So that just kind of proves to you that that theorem is true, that those two remote interior angles do add to be that exterior angle. And we also know that because this has to be 180 degrees, but all three have to also equal 180 degrees, which is why this is true. All right, that is it for 2.3.